Hello everyone, welcome back to my YouTube channel. In our today's video, we shall discuss the factors on which the resistance of a conductor depends. To study that, we shall do or study one simple activity. For that, you have to build this circuit. So the schematic diagram or the circuit which you are seeing, you have to build this circuit. Now we shall see what all we require to build this circuit. So first you require a cell, ammeter, nichrome wire and a plug key. So this is a simple circuit. Only 4 components are required, that is cell, ammeter, plug key, nichrome wire. So first you have to complete the circuit by connecting cell, ammeter, nichrome wire. So we shall consider the length of the nichrome wire to be L and we shall mark it as 1 and a plug key. And next you have to plug the key and the current will flow in the ammeter. So you note down the current in the ammeter. And in the next case, you replace that nichrome wire by another nichrome wire of length 2L. So in the first case, you have taken the nichrome wire of length L. In the second case, you have to double the length. For example, in the first case, if you have taken 0.5 meters, in the second case, you have to take 1 meter, double the first case. And that nichrome wire should be of same thickness. You should not vary the thickness. It should be of same thickness, but only the length should vary. You have to take double the length compared to first case. Again plug the key and note down the reading in the ammeter. Next, in the third case, you have to replace that nichrome wire by a thicker nichrome wire. So in the first two cases, the thickness are same but the length varied. But in the third case, the length should be same, that is L. In the first case, if you have taken 0.5 meters, in the third case also you have to take 0.5 meters, but the length is same but the thickness is more. So what you have taken in the first case, you should take the more thicker wire in the third case. And you have to note down the current in the ammeter. See, the thicker wire has a larger cross-sectional area. And in the next case, instead of taking the nichrome wire, you connect a copper wire of length L. That means if in the first case you have taken 0.5 meters, in the fourth case also you have to take the copper wire of 0.5 meter. You should not vary the length. So connect the copper wire and note down the value of the current. So here you will conduct the experiment considering 4 cases. In the first case, you will connect nichrome wire of length L, and in the second case, you will double the length of the nichrome wire, but the thickness should be same. And in the third case, you will not vary the length. You will take the length of the nichrome wire of the first case, but you will take the more thicker nichrome wire. And in the fourth case, you will take the copper wire of same length L. In all the cases, you note down the reading of the current and compare the reading whether it is same or different in all the cases. See, when you observe, you may arise some questions, that is, does the current depend on the length of the conductor? Because in all the cases, in some cases the length is different, in some cases the thickness is different. So does the current vary as the length of the conductor vary or the area of cross section vary? So for this, we will get the answer from this activity. See, what do we observe is the ammeter reading decreases to 1/2 when the length of the wire is doubled. For example, in the first case, if the current is 4 ampere. In the second case, it decreases to 2 ampere. That means if the wire length is doubled compared to the first case, the ammeter reading decreases to 1/2, and the ammeter reading increases when the thicker wire of same material and same length is used. So you can see the increase in the current when the thicker wire of same material and same length is used, and you will observe the change in the ammeter reading when you use the different material. That is in the fourth case. In the fourth case, you have taken the copper wire. It has same length but same area of cross section, but it is a different material. So the ammeter reading changes, or the change in the current can be observed when you differ the material. So from this, what we can conclude, with the help of Ohm's law, we observe that the resistance of the conductor depends on its length, area of cross section, and nature of its materials. So this is very important question. It may be asked for 1 mark. So write the factors on which resistance of a conductor depends. You have to write on its length, on its area of cross section, on the nature of its materials. And the precise measurements have shown that the resistance of a uniform metallic conductor is directly proportional to its length and inversely proportional to the area of cross section. That is, resistance is directly proportional to length and inversely proportional to area of cross section. When you combine these two equations, we get R is proportional to length by area of cross section. If you remove the proportionality sign, we will introduce a constant, that is rho. R equals rho into L by A, where rho is the constant of proportionality and it is called as electrical resistivity of the material of the conductor, and the SI unit of resistivity is ohm meter, and it is a characteristic property of the material. So you have to remember this formula, R equals rho into L by A. Based on this, you will get the numerical problems. I hope you find this video useful. If you have any doubts, you can ask in the comment section. I'll clear your doubts. So if you find this video useful, please share this among your friends and family. Thank you.